Hey guys, SimCoder here, and today we are going to start working on the feed. And we are doing this because we already have a following system, so we are able to actually know which tweets to fetch in order to display them all in our feed. So yeah, it should be pretty good, especially because Firestore isn't made for this type of action. So I'm going to show you how you can get around the Firestore limitations in order to actually accomplish this. Remember, this won't be perfect because it isn't the perfect database for this type of action. However, it should work. So yeah, let's do it. Before carrying on with the video, I just want to let you know that only around 20% of you guys are actually subscribed to this channel. So if you don't want to miss any single video in the future, be sure to subscribe and to hit the notification bell. Okay, so here we are, and the first thing that we are going to do is actually understand how we are going to fetch the posts, the tweets from the database, and how we are going to display them in our feed. As there's something that we must do because we are using Firestore for this, which again isn't made specifically for this application, for this type of applications. So we have to understand how Firestore works and how we can go around this issue. So first things first, let's go into, for example, this user, and let's see how many users this user is following. We see that this user is following 2 users, all right? And if you want to get the posts into a feed, we would have to go into to do a query to find each and every single post that has a creator that matches this ID. And by that, I say every single post that has a creator ID equal to every single following to every single user that the current user is following. All right, and there's a specific function that Firestore has which could help us with this. And this function is called where, which is a query that you can make, and you can tell Firestore to find every single document inside a collection that has one argument corresponding to any element in an array that you pass along. All right, but this is limited to 10. So you can pass along at most 10 users per query. This is an issue. However, by throwing in a loop, a for loop, you are able to divide the array of users that the current user is following into small chunks and get the information that way. So you'll understand this better in a second. I just want you to know that and understand why these type of actions are a problem for Firestore. Okay, so here we are. I have the work environment set up, so let's get on with it. And the first thing that we are going to do is to go onto feed and actually try and change this in order for it to accept and to get data from the database, or to call a function which will handle that, and to display the list of posts. So for this, we'll, instead of a stream provider as we did use throughout the series, which, remember, a stream provider will get the stream, which is a WebSocket in this case, because we are using Firestore, so that's how it works. So it gets, anytime there's an update, we get that data instantly sent to us, and then in the stream, it will fetch it will send that data to the widget that called it. So you can return multiple values at multiple times without having to restart the function. This isn't ideal for the feed because we want to, for the user to update the feed, or for the feed to get updated, the user has to update the feed manually, either by scrolling down and the circular progress bar will appear, something like that. So we want to get the feed information one time and one time only. So if the user wants to update it, the user will have to manually do it, just like Twitter. So for this, we'll use a future, and so that you understand the main difference between a future and a stream. In this case, a stream basically can return to you multiple values at multiple times. A future can only return it once. It is similar to a promise in JavaScript. So stream provider.value, and in this case, we'll say that the value will be equal to a function which we'll call up in the post service. But for now, we don't have that function. So I'm going to say null. Okay? And then we'll say that child will be equal to a scaffold, and the body will be list posts. All right? And this will return an error, obviously, because we don't have a provider in here, so we aren't able to pass along anything to the list posts, because if you remember, we are expected to get this provider from here. Okay, so now we have to actually write down the function which will get the post. So let's do it. And the first thing that we are going to do is just to come in here, and let's make this bigger, and call up the post service and initialize that variable so that we can actually make a call to that file. Okay, so now going on to post service, this is where we left off the last time that we were here. We are going to create a future function which will return a list of post model. Okay, as easy as that, nothing fancy. It is basically the same thing as this one, the get post by users, but in a future form, returning a future instead of a string. Okay, so let's write down the function. First, we want it to be a future of the type list of the type post model. Okay, and these will be called get feed, as it will be specific to each and every single user. So yeah, this is a good name for it. And it won't receive anything at the time, and it will be async, as always. All right, so we have our function structure done. I'm going to actually grab get feed, come in here and replace the null value of the feed widget future provider and say post service dot get feed. Okay, so the error doesn't disappear yet because we aren't returning the information that's necessary. And this is because before we actually get the posts, we must get the users that the current user is following, right? So in order to do that, let's save this. Okay, the error disappeared. We didn't actually even need to return anything. Great. So let's go into user.dart, and in here we are going to actually do a query to find the users that the current user is following. Okay, so let's come in here, and it can be below get user info, and this is going to be a future and not a stream again. So the future will return a list of string, and it will be called get user following. We are going to pass along the parameter UID, which is which user do we want to find the following users of, okay? And it will be, once again, async, as we are using a future. And there we go. Now we have our boilerplate code for this boilerplate function. There we go. Okay, so it will return a list of string, and this is because if we come into our database and we come into following, then we see that we have a list of strings. Documents containing just a string and not any other information, so this isn't an object, and we don't need to worry about that. Okay, so in order to actually get this information and parse it over into a list, what we are going to do is say query object, or query snapshot, better yet. Query snapshot equals to await firebase firestore.instance.collection. And this collection will be users. You are more than used to this. And then we pass along the document containing the UID that's passed along to this function. Then we'll have yet another collection for the following. And finally, we say get. Okay, this will fetch all of the information from the database. However, it will retrieve to us a query snapshot, and we want this to be a list of containing strings, a list of strings. Simple as that. Okay, and in order to do this, we've done similar things to this before, so it shouldn't be new information. we'll first create a variable called users, and it will be a final variable. Then we'll get the query snapshot, which will contain a list of users, obviously in a specific object that returned to us from Firebase. So for Firestore, so we have to parse it over. And then we say docs, and the docs will be, as the name implies, each and every single document that is in the collection that we fetched from here. Okay, so docs.map. And now when we map the information, we are able to easily say toList at the end, so that we can say which information from the document that we got from here. And remember, this iterates through each and every single document from the query snapshots, and we are able to say which information do we want to keep into the object, or in this case, a string. So in this case, for each and every single document, it will return the doc.id, which is the ID of the user that the current user is currently following. So HD5 and K4S, whatever. Those types of information. So, and then we finalize this by saying toList. This toList will make a list out of this, and in this case, we'll receive an array of strings containing the UIDs of the users. So exactly what we need. In this case, we'll return the users, save that, and there we go. So now over on to posts, we are now able to get the users that we have to fetch the information of, the posts of. So let's try and do this right now. The first thing that we are going to do is say list string users following, which will be equal to await user service dot get user following. And for the UID, obviously in this case, we'll pass along the Firebase auth instance dot current user dot UID, which is the current logged in user. All right, save that. And there we go. Now we have the list that we need. So now let's write down the query which we'll make. However, it won't stay like this, because we must do one big change due to the Firestore limitations. But let's take the best case scenario, and let's imagine Firestore works exactly like we want. So in this case, we would have a query snapshots equals to await firestore.instance.collection. And in this collection, remember, we want to fetch the post, so we say posts. Then we write down our query and our restraints in order to fetch the post. So we limit the amount of posts that we want depending on the information that we have at the moment. And the information that we have at the moment is the users following. So what would be great? What would be great is if we were able to type in where, then we pass along the argument that we want to find the users following in. So let's say that we have the list with UID1 and the list with UID2. These are the two users that we have, for example. We want to, for this where, to go into the database and to search for every single post that has either UID1 or UID2 in it, right? This would be the easiest way of doing this. And let's imagine this array has 500 users in it, from UID1 to UID2 to UID3 to UID4. You get the point. So in that case, we'd say that the creator, where in, and we pass along this data, where we say that where in user following. Let's close that up. There we go. Then we would say that we want to order by timestamp. And that we want it to be in the descending order, and set it to true. Then we say get and be done with it. So now all that we had left to do would be to simply return post list from snapshot query snapshot. And now, even though you don't see an error in the feed widget, these will slightly work, even though you have to take one other step, which I'll show you in a second. However, if you go above 10 users, which is the limitation for where these wherein can be used, so if we have up until UID 10, that's fine. It will work as it should. However, going above it, it won't work, as you can only pass 10 elements in this array. So we'll have to find a way to do this. However, if you open up the terminal, and if you are following less than 10 users at the moment, if you go to the debug console, you'll see that this error appears. The query requires an index. And this just means that because we are doing order by and we are using a where query, we must create an index for Firestore to easily get that information. So this is called indexation, and it is quite a common occurrence when dealing with databases. And in the case of Firebase, this is how you create an index, which will allow Firestore to actually do this query efficiently. So let's grab this link, open up our browser, and enter the link. You'll see that it automatically will create for you a composite index, which takes in the post collection and says that the creator has to be ascending. So when it comes to strings, so A comes before after A comes before B, and so on. So as easy as that. And this will be the ID of the creator, which is the ID of the user that created the post. And we say that the timestamp is descending, right? So that's how we are going to do this, and just create an index. And this will take some time, and the status is building, as you can see. But I'll be right back once this has finished building. All right, so after this index has done building, you'll see enable appeared, and then we are able to go into our app and try and save it to see if it reloads. And when it reloads, you see that it is actually displaying all of the information that we want. So we are following two users, the K4 and the HD5, and it is displaying the IDs and the tweets as it should. So great. Now, if we can close that up, but we have to actually handle that part where we can only pass 10 users at a time in here. So what we are going to do for this is to actually split the array that we get from these get user following, and split it into at most 10 users at a time. So we get an array of arrays of strings. This might sound complicated, but it is just a line of code, and it is actually pretty simple to accomplish using a package called Quiver. So in order to actually split this array into an array of arrays of string, and at most 10 strings per array, then we are going to make use of a package called Quiver, which contains a lot of utility packages which allow you to more easily handle some type of operations within Flutter. I use it mostly for iterables, like in this case, but it contains a bunch of other cool stuff. So the first thing that we are going to do is to import the package, and we are going to say import package, and then start typing Quiver, and it will appear. And in this case, we will need the iterables package. So let's import that. Save it, and there we go. Now we are going to, with just one line of code, do this operation that we want, which is not complex, but requires some logic if you think about it. So with Quiver, it only needs one line, and you are able to do it. So we'll say var split users following, and this variable will be equal to partition, and partition is a function from Quiver, and it will return of the type dynamic. Close that up, and we'll pass along users following and then 10, and I'll explain it in a second. So what does this line do? So partition, if you open that up, let's see if it talks. Okay, there we go. It partitions the input iterable into lists of a specified size, which is exactly what we need. So in this case, this variable will run this function, which takes in the users following, which can be an array with infinite amounts of users, not infinite, but you get my point, a large amount of users, let's say 500 users, and it splits them into chunks of 10. So this will be an array of arrays of, in this case, strings. And we can actually do inspect split users following just to see what it returns when we run this. So let's try and run this, and going to debug, inspect variable, and in this case, it returns an iterable with two items, in this case, this HD5 and K4S. But let's say we just want it to be of the type of size 1. So in this case, we want it to split this array into chunks of one-sized array. So let's see what these returns. Going to iterable, and we see that it returns of the size 1 per type. So in this case, we basically get an array of arrays of size 1. But in this case, we leave it at 10, which is the most efficient way because it returns the most amount of users possible, and it will do the least amount of queries in order to fetch the posts of each user. So there we go, size 10. Just like we want it. And now, in order to actually do this query, we'll have to loop it. So we do for int I equals to 0 to split users following dot length. So we'll go over each and every single array that's inside this array. Let's think of it like this, even though it isn't exactly structured in that way. Let's open that up. Let's grab the query and move it inside it. And this in here obviously needs to be I smaller than this. So I smaller than split users following dot length. Okay. And then we'll create a variable up top of the type list of strings of post models, better yet. Close that up and say fid list equals to an empty array. So this is the variable that will contain every single post by the end of this for loop. And then we'll need to order that by timestamp. And you'll see why in a second. So in this case, each time the loop runs, we'll say that fid list dot add all, and then we say post list from snapshot query snapshot. So basically, anytime this for loop runs, depending on the amount of users that the current user is following, obviously, it will add all of the posts that come from this query snapshot to the feed list. Now, these posts for each and every single loop that we do will be ordered in the query snapshot. However, when we add them all into the feed list, the feed list won't be ordered because we'll have a group of posts ordered, then below it another group of posts ordered, all in a succession in an array. So after we run this for loop, we must order the feed list again. And this is why Firestore isn't the best database for this type of actions, because you must do a lot in order to get information. And obviously, if you get to a large amount of posts, these will be quite inefficient. But as a proof of concept, it is more than enough, and that's why I'm going with it. So we say feed list.sort AB, open a function, close that up with a parenthesis. There we go. And now, in order to order a feed by an argument, in this case the timestamp, what we are going to do is to first get the date of the a var in this case. In this function, you basically define how you want to order the list. In this case, we want to sort it by timestamp. So we take an item A. Let's say this is an object of the query snapshot, or in this case of the post model. So in the item A, we say that the var a date is equal to a dot timestamp, right? And we do the same thing for the B. So B date equals to B dot timestamp. So if we have this item and this item right here, how do we order it? We say that we return the B dates dot compare to A dates. So this will return a negative value if B date is before A date, and it will return a positive value otherwise, 0 if they match. So in this way, we are able to, this sort function will handle everything for us, and we don't have to do a loop and do a sort, whether it is a vowel sort or something like that, or a merge sort for that matter. I would believe that's the best for this specific case. But we don't need to worry about this. We have a complete list, and we just tell the sort how we want to order it. Okay, so now we are done. We are only going to grab the feed list and pass it along in the return. So feed list, return that. And we are going to come in here, and instead of users following, we are actually going to do split users following. This is something I should have done before, but let's do it now. Element at I. All right, let's save it. And now it should be done, as it is getting only the current array that we want while we go through this loop. Okay, so now if we set this to 1, it should be the same. And it should be the same because it is, even though it is doing this loop 2 times, and we can see this by doing it like this. So let's say inspect split users following element adds that at I in this case. So we see that it runs 2 times, and it gets first the HD5 and then the K4S. So it does exactly what we need in this case. However, if we do 10 at a single time, in this case, it will return the 2 items in a single go and pass that array onto this where function. So there we go. This might sound a bit confusing, but if you dig deep into this code, you see that it isn't that complicated and it works. So for this lesson, we have to do one other thing, which is to go onto the post.list, because this isn't scrolling at the time. So I'm going to remove this physics as it isn't necessary, and it is hindering the functionality of the feed. So for now, it is working. It isn't yet displaying the user's image and username and things like that, but I'm not going to worry about that at this time. The important thing is that we have a working feed, a semi-working feed. We will work on it somewhat more in the future, as we want to, for example, do a limit on the amount of posts that are fetched. Because right now, if we have a tremendous amount of tweets in our database, we are fetching a lot of information at a single time. What we should do is, for example, when we reach the end of a scroll and we have no other posts to tweets to fetch, to display better yet, then we fetch more tweets from the database and do this recursively. Right now we are fetching everything, which isn't ideal, but as a proof of concept is more than enough, and we'll work on that other part later on in the series. So that's it. We now have almost a completely working app. Obviously, it doesn't look all that good. We have to do some work on the UI. We have to do some error handling. And most important, we have now to do the like, the quote tweets, the retweets, and the reply to a tweet. So all of that is still left undone. We are going to work on those features in the next couple of lessons. So yeah, that should be awesome. If you like this video, then please do leave a like and subscribe. And yeah, I hope to see you again tomorrow. Ciao.